Now here this is a question on Doppler's effect. So here you see that there are two submarines. One is submarine 1 and another submarine 2. They are moving towards each other. So here the velocity of submarine 1 is 50 kilometer per hour, and the frequency emitted by the sonar signal, your frequency, it is given to you 1 into 10 to the power of 3 hertz, and the velocity of the sonar waves, this is how much, 5470 kilometer per hour, and the velocity of the submarine 2, it is 70 kilometer per hour. Now you have learnt in Doppler's effect. Suppose there is a police person standing on a highway. A police person standing. The frequency of the siren emitted is say 1000 hertz. 1000 hertz. Then a person standing on the same highway, he will hear the same frequency 1000 hertz. Now suppose this person is moving towards the police person with a speed of 120 kilometer per hour, 120 kilometer per hour, then the frequency heard by this person will be 1096 hertz. That means there is increase in frequency. But suppose if he moves away from the policeman with the same, from the police person with same velocity, he hears the frequency of 904 hertz. So there is decrease in frequency. So we find that whenever there is a relative motion between two objects, the frequency heard by the detector changes from the original frequency. So the detected frequency, that is equal to frequency emitted by the source, velocity of the sonar wave or sound wave, plus minus velocity of the detector divided by velocity of the sonar or sound wave, plus minus velocity of the source. So taking this help, we are going to find out the frequency that is heard by the submarine 2. Submarine 2. This will be equal to frequency of the signal into velocity of the sonar wave, plus, we will take plus because there is shift in the frequency, plus velocity of your detector, velocity of the detector, that is Vs2, velocity of the detector will be Vs2 divided by V minus velocity of the source, that is V submarine 1, because it is emitted by the submarine 1, and it is because detected velocity is on the numerator. So if you place the value 1 into 10 to the power of 3 bracket velocity of the this sonar wave, it is 5470 minus velocity plus velocity of the submarine 2, this is 70, and then divided by 5470 minus 50. So if you calculate it, I have calculated this, and if you calculate it, you will get 1.022 into 10 to the power of 3 hertz. You are going to get 1.022 into 10 to the power of 3 hertz. This I have calculated it, and this is the result you get. Now, for the second case, what frequency is detected by the submarine 1 in the signal reflected back to it by the submarine 2? In the second case, for the second case, to solve it, let us take the submarine 1 is at rest, So, your frequency heard by the submarine 2, it will be the reflected frequency, it will be the reflected frequency from the submarine 2. This is the frequency heard by the submarine 1. This is the frequency heard by the submarine 1, received by the submarine 1. This is the reflected frequency of the submarine 2, again V plus, because there is shift, and in this case your this is the detector, so Vs1, this is your detector, S1, submarine 1 is detector, and your submarine detector is submarine 1, and here the velocity V, this is the velocity of the sound wave, this sonar wave. In this case, we have done. Now here in this case, first of all, it would be better if you treat it like this, that is, since your submarine 1, this your submarine 1 is moving with your velocity vs1, so vs1, so your reflected the frequency received by the submarine 1 will be reflected frequency of the submarine 2, that v plus vs1 by v. This will be the, since here your say submarine 1, it is moving with velocity vs1, so the frequency heard by the frequency heard by the submarine 1 will be this one. And your reflected, for calculating reflected frequency, let us consider submarine 1 to be stationary. For calculating the reflected frequency, let us consider this submarine 1 to be stationary, and your reflected frequency will be v plus vs2 by v minus vs2. Here, since you have kept this stationary, and your reflected source, see here your source is also, because reflected waves, your source also becomes submarine 2 at the same time. Source is, and it has detected it at first time, it detected it, so and the second case it becomes a source, so your vs2 and vs, so your here both detector and source becomes the same. Remember that when your submarine, for calculating reflected frequency, you are keeping submarine 1 stationary. Let us keep submarine 1 stationary. So when you keep submarine 1 stationary, so here you see that submarine 2, in the first case it becomes the detector, and in the second case it becomes the source. The same submarine 2, it becomes the detector as well as the source. So here vs2 by vs2, and if you place here, you will get v plus vs2 by v minus vs2 into v plus vs1 by v. Now if you place the value, now if you place all this value, you are going to get, you place this value. Now if you, if you place this value, this will be how much? 5470 plus vs270 by 5470 minus 70, 5470 plus 50 divided by 5470, and it is 1.045, and the value comes out to be 1.045 into 10 to the power of 3 hertz. The value of it comes out this. So here again I am telling you, in the first part it is easy. The first part is the first question: what is the signal frequency as detected by submarine 2? This is very easy, normal. But in the second part, what frequency is detected by the submarine 1 in the signal reflected back to it by the submarine 2? So for submarine 1, this frequency, it is the detected frequency. So this will be the reflected frequency, and the submarine 1 is moving with this velocity. So here, moving with this velocity, so here your reflected this frequency plus vs1 by v plus vs1 by v. Now for calculating v reflected, we consider submarine 1 as stationary. When we consider submarine 1 as stationary, so here your v reflected this will be this will be V plus Vs. So here V reflected, that means V into the sonar wave. So here this is sonar wave. So here this will be 1 into 10 to the power of 3. This I have left here, made a mistake here. So in the second case, what is the most important? When it is reflected, the submarine, at first it detected, and second it becomes the source. So velocity of the detector as well as velocity of the source is the submarine 2. So we have put V as 2, and in both case detector and source both V as 2. The most important point here in reflected rays, again I am telling you that here what happened, that is the submarine 2, at first it was a detector, then and as a second it becomes a source. So while calculating the reflected reflected frequency, here this will be the detector and the source, they are both Vs2. And for calculating we consider this submarine 1 to be stationary. And next, for since the submarine 1 is moving with velocity Vs1, so the detected frequency by submarine 1 will be V reflected plus into V plus Vs1 by V. This will be this much. So this is how we calculate it.